Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers. Welcome to the dynamic learning hub of XLR at Andheri East, a prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
All right. Good evening, everyone. I hope all are good, right? Let us continue with our day 7. Actually, yesterday should have been there, but yeah. So we are continuing today for day 7, right? Let us understand. I think when we ended the day 6, we actually have gone through some of the concepts on natural language processing, how NLP is actually linked with the generative AI, and what is the importance of natural language processing in generative AI. So this kind of basic understanding we had, and we also have seen a practical, one example, I think, or yeah, 2 or 3 examples on tokenization as well. And continuing with that part, we have a few aspects as well, right? Some of the models, how to understand, and all those things. Let us continue from that perspective. And let me share my screen first. Let me try to, so let us share the screen. Okay. Okay. So I think now you can see my screen. So this is okay. Fine. So let us continue from what we have to continue, right? Right. So the first concept is the concept of stemming, right? So we have seen one of the practical concepts, which is the tokenization, right? So at least some 3-4 sessions will be continuously practical part. Okay. So right till the usage of transformers. Let us understand few practical things on that. Okay. So after tokenization, the next important part is the stemming, right? So stemming is a very important. Actually, there are a couple of concepts which are related to each other. One is stemming and one is lemmatization. So stemming and lemmatization are concepts which are used together, and let us see how they actually function and what is the importance of using stemming. So it is basically stemming, in one word or one sentence to understand stemming is just cutting the word to its root form, right? Best example, I can take is the, example of playing. So you can think that the word playing has, different forms: playing, played, place, right? Player, right? But the root form or the base form of that particular word is play, right? From that root form, all the other words have actually come, right? So why we use this is, while building a model, these many words will be very difficult. So what we will do is we'll try to bring down the word to its base form. Okay. So reducing the word to its base form is one of the most important aspects when it comes to model building, especially in the generative AI and NLP. Now let us also see with the, okay, now let us go to three important stemming concepts which are there in stemming. The first and the foremost one is the Porter stemmer. Okay, so these are actually very old kind of concepts actually, which are even embedded into the NLP and generative AI. So the first one is basically the Porter stemmer. Okay. So I'll also tell what are the advantages and disadvantages of using stemming, all those things. Let us talk. So first, let us understand what are there. Okay. Then let us, take from there to understand how actually the things work. The first one is the Porter stemmer, right? So this is basically named as Porter stemmer because of the developer or the person who developed it. Okay. So his name is Martin Porter. Okay. So on his name, this Porter stemmer has been actually designed, or the name has actually been given. So this is a very, very old one, 1980. Okay. This is not that effective also in the real, I would say, in the real time. Why also we will discuss. So this is basically a light stemmer, right? And the use cases are, this is basically a standard one. Okay. So I would say, we say, a few things are very standard, right? So this Porter stemmer is like that one. It's a standard one. Okay. So here, if you see the Python code, right, we will see in, Colab also. But just for example, I have mentioned in the PPT. Okay. So here, if you apply the Porter stemmer to the word running, you will get the output as run. Because for running, the base word is run, runner, running, right? Ran, right? So, the kind of word, for example, like ran, right? I was just, for that, this will not be able to find that it is running. That is the problem. That is why we use different concepts also. I'll come to that. So next is, such word called as happy, happiness. Okay. So happy is the word. Okay. So for example, it doesn't know that it has to put the Y, HAPPY, no, happy, but it will identify that this ness is actually an extra to get the word to a base form. So this will consider as HAPPY, happy. It will understand like that only. It's a machine, no, after all. Correct, no? Now, next one we will see, which is the Lancaster stemmer. Okay. So Lancaster stemmer only supports English language, and this is basically developed by Chris. pace. Okay, this is bit you know bit above standard, right? It's not like just a base stemmer. It is bit more better compared to people call it as aggressive stemmer, or I would say above average, in my opinion, because I have seen these stemmers in action with the real time data. So use case is used when strong reduction is acceptable but can sometimes overstem. First of all, stemming is only having some issue that we will discuss that also. Next is applying the Lancaster stemmer, right? You can see running will give as run, happiness will identify as HAPPY. Okay, here it is able to identify. Okay, the Porter stemmer is not able to identify, right? So see the difference between the stemmers. So next is universal, and this is identifying as AL as extra, so it is taking as universe. Okay, here also again one more problem. Universe is supposed to be UNIVERSE, but that E is gone. Okay, yeah. Now some there is also one more problem in the Lancaster stemmer, is it also can produce even this universe without E is also a non-dictionary word. Now if you see, there is a high chance that it might produce a non-dictionary word also. So like maximum, right? Maxim is not a dictionary word, right? National, nat, right? So it is sometimes also producing non-dictionary words. That is one of the problems in the Lancaster stemmer. Now the third one, and bit more balanced one, I would say. Personally, I like the third one, which is the snowball stemmer. At least this one will make a bit of sense, right, in a few things. Okay, but this also has a problem again, right? So we will see that. Okay, now this is basically developed by Martin Porter only. This is a new version of Porter stemmer. Why I am telling you? Because there are methods, right? So when you apply stemming, you should be knowing that which kind of stemmer you have to actually use. Now, this actually supports multiple languages. The advancement, what has happened in snowball stemmer to the Porter stemmer, is basically the adding of multiple languages. And also, this is aggressive and conservative. So this is actually a balanced one. So use cases are, a lot of advanced projects. It is able to, or text, it is able to, refer in a conservative, I would say a balanced way. So if you're applying a snowball stemmer, the one thing which you have to be very careful is snowball stemmer, you have to give the language, which language you want to actually apply. Okay, because this supports multiple languages. The other two one, actually Lancaster and Porter stemmer doesn't support other languages. It only supports English language. Okay, now let us see the examples where you will use this stemming. Sir, you are telling the stemming, if you use like this, right? Where we will use, or how we will use, right? Let us see examples, and now then go to the app practical part in the Collaboratory. Okay, Google Colab. Now the first example is the search engines. So everyone is aware and everybody uses the search engines. Correct? No? Right? I think I'm correct. So every day you use Google for one thing or the other. Okay. Now, if you give one word called as running shoes, okay. Now, behind the scenes, what will happen is the search engine stems the word running to run. That is how this stemming works in the background. So it also shows the results for run, ran, runner, runs. This is the advantage of using the stemming. That means it is able to reduce the word to its root form, so that whatever is linked to, or whatever, I would say in a simple language, whatever is linked to the word run, that results it will show. Okay. In technical terms, you have to understand the model will be built using the term run. Okay, this is technical part. the model will be built based on the word run. So whatever maps to run will come as an output. This is the technical way of understanding. So this is two sides which you can understand. Now, to increase recall, more relative documents are retrieved even if exact words don't match. So there is a high chance that whatever is linked to run, you might get. Maybe something which is not you have given, but it is coming up which you need. That is why the search engines, this is one, just a small example. You can see e-commerce product search also, right? You search for wireless headphones for running. Stemming helps match the products listing with run, running, runner, ran, headphone, headphones, everything it will map, or it will, correct term is map actually. Computer language, if you say it is mapping, right? It is mapping to one to many mapping. So whatever is coming under run, which is linked to multiple mapping, all the results it will come. So what happens is it improves the search and more products can be recommended so that you can search from the products. This is the advantage of using the concept of stemming. So now I think you are linking to your real life examples how this stemming actually works, right? Now, chatbots and virtual assistants. So I've taken different examples so that you might link to your real time things, what you actually do, right? And how in the background stemming is working. That is very important. No, so how this concept is working in real time, you should be able to figure it out. Correct? No. So chatbots and virtual assistants. I was studying chemistry last night. Now here stemming, what it will do, studying will make it to study. So the bot better understands that studying, studied, and study means the same thing, helping it match answers more effectively. Now, spam detection in emails. So words like buy, buys, buying, bought, buyer, all these actually link to the word buy. Correct? No, this is the base word. Now, stemming all these to a root like buy helps spam filters detect patterns more effectively. That means something which is relating to buy, it can identify as a spam. Okay. Now, next is document similarity, which is the plagiarism check. So you guys use plagiarism maybe for project when you do, because you're students, right? So when you're doing project for plagiarism check, you send, right? So how does it check? One of the applications in checking for document similarity is the concept of stemming. So if a document says the student was studying hard and completed all her assignments, so and the other says she studied well and completes her tasks. While stemming, this studying makes studied and studying will be study. Completed, completes will be complete. So this helps the system detect similarity even though the words are in different form. That is how your plagiarism will be identified. Now, when to use stemming? Sir, so much of usefulness is there. Yes, it is there. But the problem is also there in stemming. That also I should tell. No, I'm telling advantages, but there is also disadvantages. Stemming is very fast. Okay, so comparing between stemming and lemmatization, when I explain lemmatization, you'll be able to compare stemming and lemmatization. But before going into that, I'll explain both stemming and lemmatization, then we'll go into the practical so that you'll be able to link better. I thought to individually tell, but now I feel in your understanding perspective, stemming, lemmatization, if you study, if you see the concepts, then going to practical, you'll be able to link that with stemming what is happening, with lemmatization what is happening. So we will see like that. Okay, so that will be that will make more sense for you. Now, when it comes to stemming and lemmatization, when speed matters than accuracy, stemming is good. If accuracy or precision matters, lemmatization is more good compared to that of the stemming. Okay, there is a slight difference between stemming and lemmatization that we will discuss. Okay, now let us go to the word. Let us go to the next concept, which is lemmatization. Okay, so together we'll see the practical part. Okay, I think it's fine for you. Now, what is the difference between this lemmatization and stemming? Here, we are saying stemming is bringing to a root form. Okay, now what happens is this will bring to the dictionary form or a base form. Best example is better, which is dictionary form, which is good. Running, run, was, be. So that means this lemmatization not only just cuts the extra. Stemming is actually, cutting the extra part which is there in the word. But lemmatization is not like that. Lemmatization brings it to not to the root word but to the base word. Okay. And it concentrates on the dictionary form or dictionary words of that particular word before reducing. So what will happen is this will make more sense. Okay. It doesn't, yeah. See, I mentioned here. See, unlike stemming, which chops blindly, lemmatization returns a valid words. Here, when you have seen, what is this word? See, happy, H-A-P-P-I. Happy is not H-A-P-P-I. Correct, no? So it is wrong, no? According to the dictionary. Correct? So it doesn't give simply by just cutting it down, because lemmatization works on the base or the dictionary form of the word. So that is very important. That is why it is slow compared to that of the stemming, because stemming just cuts. Correct? No. Lemmatization doesn't just cut, right? It searches the dictionary, it searches the mapping word, matching word, then it gives the result. So accuracy and precision is more in lemmatization, but speed is less. But in stemming, speed is more, accuracy and precision is less. That is the difference between lemmatization and stemming. Now you can see the real world examples of lemmatization. Now, if you see the example, he was running through the forest. Okay, so running will be run, was will be. This is what it does. So this ensures that the search engine also retrieves he is running, he ran yesterday, he has been running. So because it was be also, no, so it will take been and all those things which are linking to that of the concept. So that is how lemmatization is more accurate compared to the stemming. Now, email sentiment analysis. What is the text? She loved the product and wrote reviews. Lemmatization is loved is love, wrote is write, reviews are review. So help system identify core sentiments and actions much more better. Okay. Now e-commerce examples. I hope these examples are matching to your everyday, scenarios. So a user types, I am buying wireless headphones. So buying is buy, earphones is earphone. So here in recommendation systems, it helps to identify the exact understanding and intent without creating any mismatches. Next is language translation. The children ran home. Ran becomes run. Okay. And this allows translation models to find the correct equivalent in other languages. Courier in French maintaining tense and meaning. Okay, we will come to translation part also. We will use the transformers technology. I'll show you that also. I have it in my agenda as well, to how to run task in generative AI and check how things actually work. So we will also do the translation part. Okay, because even the translation is basically a generative AI task counting. So now one more example, which is chatbots and voice assistants. So user says, I'm feeling tired. I've been working all night. Now, lemmatization will make working as work, feeling as feel. So, would you like me to play relaxing music? The assistant will respond. Because I am saying that I've been tired from work, it will understand and it will tell something similar to how how do you actually use the assistant. Based on that, it will learn and it will give you the output. Next is text summarization. So document contains students studying, students studied, students study. So lemmatization will bring all of them to student, whatever it might be, students, whatever it might be. It will bring to the base word, which is student, and studying, studied, study, everything it will bring to the base word study. So here for studying and study, study you have. So you have the y. But here for studied, stud, you don't have that y. Stemming will give you studi. Okay. So, but lemmatization will give you, because it will identify the base word or root word or the dictionary word for studied, which is study. So that is how the the precision and accuracy will be more good compared to that of stemming. Okay. Now let me share my collab. Okay. So if you have any questions, you can just put it in the chat. Okay. Now, meanwhile, I'll share my collab. You'll see the practical part. Okay. Then we'll go to the stop words. Let me share my collab. First stemming, and then we will see lemmatization also. We share stemming. Yeah. Okay. So everything I have. Stop words. Sorry. Okay. Now let us see stemming first. Okay. Now let me run once again. Okay. I've ran it already. Just again to show you, just running it. Okay. Now let us start first by stemming. Okay. So stemming will be inside the NLTK library. That is the thing, with the tokenization also we have seen. Okay. So stemming will be inside the NLTK library. Okay. And here I have mentioned that only NLTK, which is Natural Language Toolkit. Okay. Now, for importing or using the library, the first thing what we have to do is import the library, which is import NLTK. And since we are applying stemming, right, this stem function will be inside the NLTK. I would say stem module, correct? No, module is the correct word. You can see here, right? So the module, which is stem, right, it is inside the NLTK library. So this is the library. Okay, so it will show here. See, it's actually a library. Okay, see, it is showing here module, but here you can see Natural Language Toolkit is an open source library for natural language processing. Okay, so actually here it should not show as module. It's actually showing, it's not a module, it is actually a library. Okay, so yeah, don't get confused by that. Okay, so NLTK is a library and stem is a module. That is correct. Okay, stem is a module. Okay, and this porter stemmer is a function. Okay, here it is not showing that it is a function. Anywhere it is showing. I don't think it is showing any. Just a definition and about about this Porter stemmer. It has given some information. Probably you can try it later. Okay. So it's given by Martin Porter, and it's Martin Porter's website and all on that. You can check that later. Okay. So here we have given the Porter stemmer. Okay. And the other method which we have seen is the Lancaster stemmer as well. And we also have the snowball stemmer. So even the snowball stemmer is given by Porter, and this is in multiple languages. But Lancaster stemmer is not created by Porter, right? So this is given by some other person, right? So I think here just the examples they have mentioned. Okay, no problem. So here in this stem module, we have the Porter stemmer, Lancaster stemmer, and the snowball stemmer. Okay, so till here I think you are absolutely clear. Now, for tokenize, we have seen in the last session that in the NLTK library, we have tokenize module. Tokenize is nothing but giving tokens to the words. In this tokenize, we have sentence tokenize and the word tokenize. So we have two different kinds of tokenize. Here we are importing the word tokenize. This word tokenize is a function. Okay, so this function, so now for this stemming example, we have imported the tokenize as well as the stemmers. Okay, now to download or use these, we have the NLTK, which is nltk.download. Okay, in that we have something called as punct. Okay, this punct, if you are using in Colab, you need to use punct_tab also along with punct. Okay, so this is one small thing which, because sometimes what happens is if you are using in Jupyter Notebook or Jupyter Lab, and if you are using in Colab, a few things will be here and there will be different. Okay, one good thing is, if you know how to code in Jupyter Notebook, it is sufficient, because if you don't know in Colab also, if you use the same code, right, if there are any errors, here what will happen is Google Gemini will actually help you. See, here you can see. Okay, so you can, if there are any issues with the code in running, Gemini will ask that can it fix it. Okay, you have to tell that to fix it. Okay, so it will fix that code. Okay, so you need not remember for both Jupyter and Colab. Sometimes it is difficult to remember because a few things are different. For example, if you see here, there is something called as punct tab. Correct, no? If you give this punct tab in Jupyter Notebook, it will show you an error. It will not run. Punct will run in Jupyter, but it will not run without punct tab in Colab. So we have to put punct as well as punct tab in Colab. So these are the small things which will be there that you will be able to understand with time. Okay, so now let us take one example. Why I have taken this example is to see the difference. I have taken one more sentence also, that also I'll show. What I have done is I am taking a word. It's not actually a sentence, but to show you the difference between the word, I am taking the sentence like this: studies, studying, studied, so that we will see how player it was converting, played, playing, happily, happiness, studied, how it is converting, we will see. Okay, so here we have used the word tokenizer for the text. Okay, and until here it's clear. So because this tokenize function we have used in the tokenize practical as well. Now coming to the stemmers, For Porter stemmer, you need not mention whether it is English or some other language, because Porter stemmer and Lancaster stemmer are basically developed only in English. Okay, so Porter stemmer and Lancaster stemmer doesn't work with other languages. It only has English language. But it is not like that with the snowball stemmer. So snowball stemmer, it has multiple languages. So in the bracket, you have to give which language. So you want it in French, whether your text is in French, whether it is in Japanese or Italian, whatever, which Spanish, any language, what you are giving, that you have to mention if you are using a snowball stemmer. Okay. Now here you are applying the stemming. Okay, so I have segregated so that we can see the difference. Okay, now here you can see that I have mentioned the print function. Here you can see 13, 7, 9. It is nothing. It is just the length of that particular. So for example, here for word I have put 13. So here it will leave total. It will count total of 13 characters. So see, why I have given like that is to have a gap between, or else it will come close by. Okay, so to show the difference, right, it should be very comfortable for you to understand. No, now it looks good for you to compare, correct? No, that is why I have given that gap. Okay, so here I have given, see, I have given 7. For example, let me change here to 10. Okay, instead, okay, let me change to 10. Okay, now if I run, you will be seeing a 10 space. See, before this was space was less. Now it is more. Okay, so here also if I give 10, so everything will come 10, 10, 10, 10, 10 distance. Okay, this is just the distance between the words. Okay, now if you see the output, now let us concentrate on the output. Anyway, these text words are here, the original word. Okay, so let us forget about what is there in the text. Now let us go to the word, what it is giving. So studies, Porter stemmer is giving study. This is wrong, absolutely wrong. Snowball is also giving wrong, right? Only here Lancaster is giving correctly. For studying or studied, here Lancaster stemming wins. Let us vote for all the three. So here Lancaster wins because it is correctly predicting the word study, STUDY. Because there is no such thing called as STUDI. There is no such word, right? Study means I should not be I, it should be Y. Correct? No, according to English language. So Porter stemmer and Snowball stemmer have failed to identify the word study. Okay. Now let us go to the next one, player. For player, it is taking player, which is Porter, and Snowball also same. It is taking play. Play is actually correct. Player, played, place. For everything, the root word is play only actually. So in this case, even for playing, played, right? For playing and played, Porter and Snowball is able to detect correctly. Okay. So not very accurate or a very good measure, Porter and Snowball. Lancaster is somewhat better compared to Porter and Snowball. That is why we don't use Porter and Snowball much actually in reality. Okay, so Lancaster I use. First of all, I am not a great fan of using stemming also. I use lemmatization because lemmatization gives you better results compared to stemming. But why we are learning is to also understand what kind of concepts are there, how to overcome that, what we can use, what is the best one which we can try. Now, let us go to the next one, which is happily. Happily, happiness. The root word is happy, correct? So here also our Lancaster stemming is more successful in predicting the word happily and happiness as happy. But here Porter and Snowball stemming has not predicted correctly. Now let us see one more example. You might understand more in a better way. Now here I am taking a larger text. Okay, I am taking a larger text. Okay, so larger text exam. Now here if you see, for importing of the library, you have imported the NLTK, correct now? After that, we have imported the sentence tokenizer and the word tokenizer. This time, because we have bigger sentences, for the first sentence, I have not taken sentence tokenizer because we have only one sentence. What it will tokenize? The same word tokenize, sorry, sentence tokenize, the same sentence only it will give. What is the use? No use, no. If we have multiple sentences, you can use the sentence tokenizer. If you have only one sentence, no need to use the word tokenizer. You can use the, or you can only use word tokenizer if there is only one sentence. If you have multiple sentences, then you can take word tokenizer as well as sentence tokenizer. Now for stemming, you already know what are the three kinds of stemmings you have, right? Porter stemmer, Lancaster stemmer, and the snowball stemmer. And punct we have taken. Okay, and let us go to the text. Okay, I have actually given a huge text. Okay, so let me run this. Okay, so the words also here, see, for one line how we have the table. Now if the example is bigger or the text is bigger, okay, stemming is fast. I told you, stemming just cuts. Lemmatization will take, if you give a big, so from 100 lines, you can see the difference between stemming and lemmatization. Lemmatization will take a lot of time to tokenize or apply lemmatization. Now here if you see word tokenize, we are applying. Okay, fine. And here anyway we are not applying sentence tokenize. Okay, actually simply I've just given, not required actually. Okay, now here all the three we are applying, so the same syntax only, you'll be able to understand it very easily. Okay, so here since the words are a bit bigger, I have given 15 for the original word and 10 for the stemming words, which is Porter, Lancaster, and Snowball. Okay, now if I see here, it starts with the, so the predicted correctly. Connections, it predicted connect, which is correct. For between, it has taken between. For natural, it has taken nat. That is why only I don't like stepping. What is this nat? Natur. Correct? No. So it is illogical. It doesn't think that this nat is not existing inside library. Dictionary. Simply it will give, cut and give. Okay, that is the problem of stemming. That is why I have taken a bigger sentence also to show you the difference. Okay, so I'm not going into each word. You can, anyway, I'll share the Python file. You can just try it later. Okay, so for grown, it has, okay, somewhat better. For have also, Porter and Snowball has given better output. For intelligence also, artificial, sophisticated, right? For, okay, anyway, for is a stop word that I'll show you later. To is also a stop word. Anyway, we'll remove these stop words. Okay, so this is the approach what it has actually taken. Now going down, we have one function called as counter. Okay, so you have a function or a module, I would say, collections. Okay, so collections will count how many, or the words repeated how many times. Okay, now this counter, it just counts. I think somewhere here you can see the definition. It just counts the number of times the word has actually repeated. Okay, so here you can see that how many times a particular word has actually repeated. That is the use of using this counter. If you don't want, no need. Okay, just to show you as an example, I have taken. Now, let us go to the more useful one, which is the lemmatization. Okay, so lemmatization is more sensible and more reliable. Okay, but this is stemming, right? This is lemmatization. So this is more, I would say more effective. Okay, so this is more effective and it is more practical and more accurate results this will actually give. Now here we are applying the word net lemmatizer. So word net lemmatizer, okay, is the most famous lemmatizer which we actually use. Okay, so this is the one of the accurate. We don't have multiple lemmatizers like how we have for stemming. Okay, so for stemming, proper stemming, we have three, right? Porter, Lancaster, and Snowball. For lemmatizer, we have only one, which is WordNet lemmatizer. In that only, it has the dictionary, it takes the root form, correct base form, right? It will check. So this part here we have the word which is WordNet. Okay, it's a corpus, I would say. Corpus is nothing but a collection of huge amount of words. Now we are applying the WordNet lemmatizer. Okay, so let me run this code. Okay, and let me print the output. Now, if you see carefully, your results will be much, much, much better than what is there in the stemming. So lemmatizer will give you better results. Let us confirm before coming to a conclusion. Now, anyway, the is a stop word. We'll come to, we'll go to the stop words later. Okay. Children, child. Correct? Absolutely correct. Right? Because the base word for children is child. Now, were, nothing can be done. So running, okay. So running only it has taken uh not that 100% accurate, but fine, somewhat. And is any stop word, had is also stop word. Better, grades, it has taken as grade, than before is before. Okay. Now we'll go to one more lemmatizer, okay, which is POS, aware lemmatization. POS is nothing, we will see here, okay, POS is nothing but parts of speech. Okay, so we'll go to that parts of speech also. Why it is important, we'll go there. But there is one more lemmatizer, which is POS lemmatizer. Okay, so to use this POS, we have to give the POS tags. Okay, this POS tags is a parts of speech tagger. Okay, so this will also check the words whether it is actually coming under a proper parts of speech. For example, if you actually check this word, for example, better, it actually has some parts of speech or not, it will check. It is coming under, I think there are 8 parts of speech, correct? Verb, adverb, adjective, pronoun, noun, correct? So verb, adverb, right? Conjunction. So either it is coming, so any word, noun, pronoun, right? So it should come under that 8. Any word should come under that 8. So is it coming under that 8 or not? This POS tagger will check to make, see, a particular word, if it is coming under the, if it is lemmatized or been cut short or reduced to the base word, if it is coming under the parts of speech, that means it is a proper word. We don't have a parts of speech for which words which are not proper. Okay, so this is like one more confirmation, correct, that yes, my lemmatizer has done okay or good. Okay. So anyway, tokenize, you know that we have word tokenizer. And for lemmatization, we use the WordNet Lemmatizer for stemming actually. Okay. So because that actually this lemmatization is also in the function, it is also in the function stem. Okay. So don't get confused. Stemming doesn't only mean, uh, you know, those three, Porter, Lancaster, and Snowball. Even Lemmatizer comes under stemming only, but Lemmatizer works in a different way. This Lemmatizer is also put inside the stemming. So don't get confused if you are learning for the first time. Okay. So this directly will be in NLTK only, this POS tagger, parts of speech tagger. POS is nothing but parts of speech. So for this parts of speech tagger, we need couple of things. Okay. These two, which is averaged perceptron underscore tagger. Okay. So this is important. Along with that, underscore English is also very important if you are using English. Okay. So punct anyway important, which we use for NLTK, and WordNet we use if you are using the WordNet Lemmatizer. Okay. So here we are giving the WordNet Lemmatizer, and here we have given the children were running and had better grades than before. Now, after we apply this parts of speech tagger also, here we have applied C parts of speech, right? So that is how it actually uh, links. Okay. Now, once we ran that, it is lemmatized as the children child were be. Okay. So this DT, NNS, VBD, CC, that is actually a code. Okay. So in parts of speech tagger, I will show you. Okay. So don't get tensed. So I'll show you in the parts of speech tagger which kind of parts of speech has which kind of code. Okay, you need not break your head too much, don't worry about that. Okay, so here we can check that better, it is giving as good. Why it is able to correctly predict is because of the parts of speech. It is also checking the parts of speech. That is why POS tagger is also important when we use the lemmatized. Okay, now let us go to one more text. Okay, so this one also we will run again. Anyway, I've run all. Again, I'm running for you. Okay. Now let us see. With a larger text. Okay. So a big text I've given. Now here I have used the WordNet Lemmatizer, and I have given the parts of speech tagging and the word tokenize. Now already average perceptron tagger, punct, and WordNet. Okay. Now here I am applying the function for parts of speech tagger. Okay. So this is a standard code. Don't worry about how to identify the parts of speech. Okay. So it will take care. You just put this code. Okay. So this is a standard code for identifying the parts of speech. Now, here we are applying the tokenize, and we are lemmatizing the data. Okay. So this is also a standard function. Only here, if you want which kind of column, you have to give in the print function. Okay. I've just taken for all. I've taken a standard syntax for you to understand. Okay. Now, once we lemmatize, right, forget about the parts of speech codes, what it is giving. We'll come to that later when we go to the parts of speech. Okay. So for lemmatize, artificial intelligence transforming, it is transform. Correct. Right. Rapidly is rapid. Also, it can take rapidly only it has taken. Okay, fine. So investing, invest, technologies, technology. Correct. Absolutely. Automate as automate, efficiency, efficiency. Developers is developers, intelligent is intelligent, language is language, recognize, revolution, predictions is prediction. Correct. Right? So it has correctly predicted the words. Okay. So this is about the stemming and lemmatization. Okay. So what we'll do, we'll just go for a break. So if you have any questions, just ping it in the chat. Okay. So after the break, I'll just answer the just answer the questions if you have any. Okay. Okay. Fine. Think no questions. Nobody posted anything. Okay. I was just waiting. Any questions will be posted. Not sure. No doubts in the concepts what we have discussed. Okay. Fine. Okay, fine. Then what I'll do is I'll continue with the concept. Okay. Uh, Let me share my screen. Okay, so we have seen, let's go back quickly. We have seen the stemming, right? And then we have seen different types of stemming, and then we have gone to the lemmatization, right? And right, all different. We have seen the examples as well, right? The practical part in Python. And now the next concept is the stop words. Okay, so stop words are, I would say it's very important because it reduces the size of the text, because it is very important to, I would say, to reduce the unnecessary words, right? So that is what these stop words actually do. So these remove the words which do not have much of meaning in it, or not meaning. I would say less significance. Okay, so which having or which doesn't have much of significance, those words will be actually removed. Okay, now coming to the stop words, there is a few words like is, in, at, the, and, am, and, of, for, right? So all these things come under stop words. Okay, so this, if we apply the stop words, these words in the sentence will be removed, so that our tokenization or lemmatization or building a model becomes more easier with the removal of the stop words. Okay, so some real world examples you can see, where what is the capital of India? So what is the of will be removed. So capital is what? Capital and India. So what will happen is processing will be much faster. Okay, so processing will be much faster when it comes to if you remove the stop words. Now Google removes the stop words to focus on the core intent. Okay, so if you just give capital of India, improves search accuracy and performance, because the words it has to process is less. Okay, next is chatbots and virtual assistants. So can you tell me where my order is? Okay, so stop words are removed like can, you, me, where. So tell order. So it will help the bot to understand that the intent is to track the order. So by focusing on important keywords. Next is e-commerce search. So example, Amazon. So search input shoes for running in the rain. So stop words is for in the shoes. In the query becomes shoes running in the rain. So enhances product search relevance and filters the matching products efficiently. Email spam filtering. So this the email text is, this is the best investment opportunity for you. Stop words are this, is, the, for, you, everything will be removed. Only tokens are nothing but the tokenizers or tokenization, right? That is what we have done, right? So only tokens will be left over, are best investment and opportunity. So by this, it can classify by detecting the high impact words. Okay. Now, movie or product review sentiment analysis. So review is, I don't think the movie was really good. So I don't the was really think movie good. So helps the NLP models focus on sentiment bearing words like good, bad, love, hate, etc. So which will help in optimizing or helping the model to search fast. So healthcare systems input, I need help with my blood pressure report. So stop words are I need with my, and the keywords left are help blood pressure report. So streamlines medical query understanding. Okay. Now let us see the concept which is parts of speech tagging also. Okay. So we will see the stop words and parts of speech tagging concepts, and then we will go into the practical part of parts of speech tagging as well as the stop words. Okay. Now, parts of speech tagging is basically the process of assigning grammatical categories like the noun, verb, right, adjective, etc. to each word in the sentence. So I think everybody knows what is parts of speech. So in a simple way, right, easy to understand is, right, the cat sat on the mat. So there is a code word that is important. We know parts of speech, but there is a important thing here, which is to understand that what is a noun, what is a verb, what is a preposition. So in indicates preposition, right? In the output we have seen, right? So NN indicates noun, DT indicates it's a determiner, VBT indicates it's a verb. So the examples are POS. For the POS tagging, parts of speech tagging is text to speech systems. The sentence is read the book, is read pronounced as read, present, or read, which is the past tense, the problem. So for this, the parts of speech tagger will identify that read is the present and read is the past. Okay, so VB, VBD. Okay, you can see here. Okay, so VB is nothing but the verb. D indicates the past tense. Okay, P indicates the present tense. So used in speech synthesis to determine pronunciation based on context. Because we know no, in generative AI, right? The context-based understanding. So how it is happening? By these kinds of concepts. This is the base, and this is the foundation for understanding for the generative AI models. So next is chatbots and virtual assistants. User book of light. Book can be a noun or a verb. POS tagging identifies it as a verb based on sentence structure. Helps bots understand user intent more accurately. Okay. E-commerce search is green dress for party. So green is nothing but JJ, right? Dress is noun NN, party is NN. The system knows green is a descriptive adjective, improving product matching. So improves the systematic, or you can say semantic understanding in search and recommendations. So next is grammar checking tools. Okay, she go to school yesterday, right? So go is a verb which is grammatically incorrect with yesterday, which is a past context. So this suggests a correction, right? You can see the suggestions and all, right? This is basically done by using the parts of speech tagger. So NLP plays a very, 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 very important role in generative AI. Very means very. You can write 100 times very. So suggest the correction. So she went VBT to school yesterday. The POS tagging context supports the context-aware grammar corrections. So this is done, right, by the POS tagger. So named entity recognition. So I'll come to this named entity recognition later. Actually, this is one more concept. Tomorrow we will discuss about that. So this is just to this what will have what this NER will do is name entity recognition. What this will actually do is it will identify the person, name, location, organization, right? Company, for example, Apple is a company, right? It's an organization. So for identifying a few things like name, location, organization, even this dates also, like important dates, right? Important dates, those are also coming under named entity recognition. Okay, so this we will see tomorrow. Now let us see the practical part of stop words as well as the parts of speech tag. Okay, so let me share the. Okay, just give me a minute. Let me share the so stemming and lemmatization is done. Okay. So, okay. So stop words and this one. Let me share. Okay. I think you can see my screen right now. Now let us go to the stop words. Okay. So if you see here, there is one. I think this you are aware of already, right? Which is for NLTK library, right? And the thing which is you're already aware of, this is the word tokenize, right? So word tokenize, already we have an understanding about it, correct? So the now let us go to the new one, which is new for you in these three. That is stop words. So stop words is actually a function. Okay. This is inside the module corpus. Okay. So inside the corpus module, you can see the stop word function, which is actually there. Okay. So next is, next you can see punct, which you already know. And the new thing which you have to download is the stop words, which you are using here. Okay. So apart from that, punct tab already you know, right? Now let me give a text. Okay. So now let me give a text. Okay. So now you can see the text and let me run all. Okay. I'm just running the runtime again. Okay. Yeah. So it's running again. Yeah. Let it run. Let it execute. Then I think it's done. So I think it's done. Okay. Now let us see here the text. I have given a text. Okay. Here you can give any text. That doesn't matter. Okay. Just a sample text I have given for you to understand. Now here you can see the word tokenize, and you're not new to this word tokenize. So already we have seen this, correct? Now here, this is what is new, which we are giving here. So we are giving the stop words dot words, and here we have to mention the corpus, which kind of language. Here you can see. So this stop words dot words is the corpus. In this, we have to give the language, and the language which we require is the English language. Now, here we are giving to filter the tokens, and now we are printing. Now, what happens is, this is the original tokens without just word tokenize. That is why we are doing the word tokenize first. Why? Because to check the difference between the original tokens and the filtered tokens. So filtered tokens is nothing but after removing of the stop words. Okay. So after removing the stop words, what will be the output? Now, if you compare here, here artificial intelligence, here is gone, right? Here transforming is there, but is gone, right? Because it's removed, because it is a stop word, right? So it has removed correctly, absolutely. So industries, it's not a lemmatizer, right? So word will be the same, but only the stop words. So the is removed, correct? I told you the is also a stop word. So globe is there, right? And here if you see, dot not required, removed. It, stop word, is stop word. So directly only used is remaining. So directly after the globe, it's used. In between, all the three are gone, right? Then in is a stop word, so removed. Healthcare is there. After that, comma is removed. Finance is there, comma is removed. Education, you can see the difference. See, before removing the stop words, see the tokens. After removing the stop words, see the tokens. See, the list has become, I think, some 20-30% has reduced. Correct? So now, with such a small sentence, you imagine this much of difference. If you see a sentences, for example, like a reviews, right? Big paragraphs and text. Now you can imagine the amount of difference what this stop words actually bring to the table. Okay, so that is how, or that is why actually the stop words are very important to use. Okay, now let us go to the next one. Okay, let us go to the next one. Here, this stop word concept already discussed, word tokenize already discussed, and here punct, stop words, everything. Okay, now text also given, little bit bigger text I have given, not much difference, some 3 lines text. And here first we do the tokenize to see the difference, obviously. Then before cleaning, the length of the tokens, and after cleaning, what is the difference. Okay, now here if you see, before removing the stop words, the total number of tokens or words which we have is 76. That is why we have given the length function here. len, length. A length gives the number of words or number of tokens, right, in that particular sentence or paragraph what we have given. So here if you see, there are 76, and you have applied the stop words, and after applying the stop words, it has come down to 39 from 76. So you can see that it is almost half. 76 half is 38, right? Here 39 is there. So only a small difference is there, but it has a difference, right? And here you can see that what are the words which can be deleted. So you can compare that what are the, I think now you would have already understood that what are the stop words which are actually removed. Okay, or which are called as stop words. So you can see the line here. Okay. Right. Now let us go to the third one, which is counting using a data visualization. Okay. Now here we are counting for the filtered tokens. We don't want the unfiltered one, no? Okay. So we don't want the unfiltered one. Okay. So we are using or plotting the graph for the filtered one. Okay. So here you can see that I am giving a function frequency. Here you can see frequency is nothing but counting the number of times a particular word is actually repeated. Okay, so this you can just use by the counter here I've given, but last actually I think for Lemmatizer we have given like that, right? Here the only difference is from that to this, here I have given the data visualization. Okay, so I'm counting the words through data visualization. So here you can see the graph. Okay, so the most repeated word is NLP and human, which is repeating 2 times. Okay, So the next best is repeating once in the top 10, which are natural language processing, subfield, artificial intelligence, AI enables. All these are repeating once. Frequency is 1. Okay. The NLP and human are the words which are repeating twice. Okay. So that you can actually plot. Okay. So you can just use the counter, or you can also use it to count. Okay. So let me download this. I'll share these things with you anyway. Okay. Fine. Okay. I'll close later. Now let us go to the next one. Okay. So parts of speech tagger. Okay. So now let me go to POS tagger. Okay. Now let me run this. Okay. So if you have more than 3, it will show to close. You can close them and you can run. Okay. So maximum 3 can be running. Okay, in collab. So it's executing. Just give me a minute. Okay. I think it has executed. Now, okay, then now if you see here, we have used the tagger. Okay, for parts of speech tagging, we have used the tagger. Okay, so this about this tagger, I have already shown you. Correct. So punct NLTK. Okay. Okay, so already punct tab we have used, no? That's why here, even if we didn't, here anyway we have given, but even if you don't use also, it will take, no problem. Okay, if it is asking for, you can give. Okay, anyway, if it is asking, I just mentioned it. Okay, because usually I don't give this punct in Jupyter. It is asking it in collab only. So, okay, yeah. Now, okay. Right. Right. So now importing the necessary libraries which are used for this parts of speech tagging, and these 4 which we are which we need, we are importing. Okay. So that is whatever we need. Now here we are giving one sentence, which is Google is investing in renewable energy projects in India. Now here we are applying the word tokenize. Okay, and also the parts of speech tagging. Now here it is giving parts of speech along with the tokenizer. You can see renewable, it is giving JJ. In, it is giving IN. Energy, it is giving NN. NN is noun. So for projects, so along with tokenize, it is giving you the parts of speech tagger as well. Okay. So let us go down. The next thing is, okay. For your understanding, I'm just keeping this. Okay. So you'll understand better. So yeah. So this one anyway, right? And this is one more. Okay. So let us run this again. Okay. And here you can see the tagger. Okay. This is, if you don't give like a normal thing, if you give, you'll get it like this. Okay. But if you mention here that you want the word to be tagged like this, okay, so you can give. Here, I think this much of space is not required. Probably 10 is fine. Yeah. So I've changed the word length to 10. Okay. So now you can see that for each word, it is actually taking the tagger. Okay. So for each word, it is giving the parts of speech for each and every word. Okay. Here we have not applied the stop words, no. So that is why this at is in a everything is coming, right? Okay. Now let us go to the next part. Okay. So here again we are doing the tagging. Okay, it's a relatively bigger text, and you can see the tagger. So I think 12 will be sufficient. So this distance, we can only identify by how much of length of this word is basically is. So once we run only, we'll be able to figure it out actually. Based on that, we can change accordingly. Here I've changed it to 10 now. So the same thing here, if you want, you can change it to 11, 12, 13, 14. So if you feel this is very nearby, you can give 14, so that you'll get a decent amount of distance between this word as well as this one. Okay, that is one thing. And the other one is, let us go to one more sentence. I think this one I ran it again. Here again, I'm giving one sentence. Okay, it's again a big one, and I'm giving this average perceptron tagger is the standard one. These things are very standard. You can just if you just Google search also, you'll get it. The functions what you need for a tokenization, for parts of speech tagging, right, stemming. So these are pretty standard, and standard things which you have actually. So by usage of or using it multiple times, you will be automatically uh, uh, understanding or remembering it. That should not be a problem. Okay. And when we run it, okay, for this sentence, it gives the parts of speech tagging. Now let us see that it is giving tagging here for each sentence. Okay, for each sentence, it has divided one line between. If you can see, for natural language processing in the field of AI that focuses, for the client, it has put this, and then it enables machines, again this one more line. Okay, and this NLP powers real world, again one more line it has put. Okay, so that is how it is giving the parts of speech. So this is one thing, and next is which is counting the number of times it has occurred, which is the frequency. Okay, this one is not required anyway. I'm doing this. Okay. So here you can count. This will actually count all the tags which are actually there. Okay. So it is counting here that how many are there, and here you can see that noun has 9 times. Noun has been repeated. The word noun has repeated 9 times. Okay. That means in that particular words, right? There are 9 nouns. Correct. So like that we have, this is DT is determiner, VB is verb. Okay, this is just conjunction. Yeah, like that we have. Okay. Now next, let us visualize this. Okay. So we can visualize this, correct? So here you can see that how many times, how many have been actually coming in. So here you have seen the number now, right? But if you want to, if there are multiple, or you can say if you have many. Anyway, see, these parts of speech are limited only. So, you can easily see, okay, it will anyway, display from descending order only. From more to big only it will. So here you can automatically see, But still, if you want to visualize, okay, so if you still want to visualize, you can actually uh, visualize by using the matplotlib. So here you can see the matplotlib. So matplotlib is basically a library in Python which is used for data visualization. Okay. So we have matplotlib and seaborn. Okay. So in coming concepts, we will apply also a few basic libraries in Python along with the advanced libraries which are used in NLP, deep learning, and generative AI as well. Okay. And here if you see, yeah, just want to tell you this also. You can see this PLT. PLT is nothing but the alias name, right? It is basically an alias name for matplotlib. Okay. So if you give PLT, that means every time if you give PLT, matplotlib is actually called. Okay. So it is basically calling matplotlib by using one alias name. Okay. So that alias name is nothing but the PLT. Okay. Now here you can see that figure is nothing but the figure size, the size of the figure, what you want as an output, the size. Then you have the bar. So the graph, which kind of diagram you want, right? So you can give bar if you want a bar graph. And you can give the title here. So whatever you give as a title, okay. So whatever you want. So for example, here I change it to in the text. So it will change in the text. See. So whatever title you want to give here, okay, it will take. And next is the POS stats. Okay. Here you can see X label. X label is nothing but the x-axis name. So x-axis name, what I've given is POS tags. So you can see this x-axis name POS tags. Okay. And for Y label, I can see I've given frequency. Okay. So for Y axis, you can see frequency. Okay. Then this grid is nothing but the background grid. Okay. So here you can see line style I have mentioned. See. Okay. So this alpha is nothing but the size of the bar graph. Okay. And here we have given true. Okay. This indicates the frequency, which you are giving. Okay. And here is the layout. Okay. And show will show you the graph. Okay. Or it will actually distribute the graph. Okay. So this is what basically the parts of speech is. Okay. So if you have any questions, you can ask. Um, Probably this one also I'll share it with you guys. Okay. Yeah. So if you have any questions, you can ask. So anyway, today I've not given much time for you to ask questions because I had a few concepts to explain. I think 4 important concepts in NLP which are related to generative AI, because I'm focusing on concepts which are directly relating to generative AI, because our session is on Gen AI and Agentic AI, right? So which is more linking and which is more contributing to the generative AI, that concepts I'm actually touching. Okay. So if you have any questions, you can just post. We have a bit of time actually. If there are no questions, probably we can cover one more concept. If um, we have next named entity, this one, named entity recognition. Okay, I don't know that can be covered or not. That's why I just stopped at 4. Yeah, if you have any questions, we will see. Or probably I can just start. Maybe practically we can do it tomorrow. Maybe theoretical we can do. So just let me know if you have any questions. I'll just wait for a couple of minutes if you have. So based on that, we will take a call. Um, Yes, you can run. That is not an issue. I think one girl has messaged. Yeah, okay. Yes, you can. Anyway, I'll share you the Python file. So probably you can run it in Colab, Jupyter Notebook. You can pull wherever you want. That's why I directly usually share this IPYNB file because it will be easy for students also to use that. If you directly import that file into your Jupyter, you can actually if you can directly run what I have already given. So from there you can learn. So that's why usually I share directly the IPYNB file. Okay, so that you cannot only open in your laptop. That you cannot open. You have to import it, or there is one more option. If you're not using Jupyter Notebook, you do one thing. You just put the file, Python file, in your Google Drive. Okay, just create a folder, right? Just put Python files or something like that. Just name it in your Google Drive. Just put it whatever IPYNB files I'm sharing, right? So that you can just put it in the that you can directly put it in the uh, you know okay, that you can put it in the Google Drive. And if you directly, if you double click on it and open it, it will open in Google Colab directly. Because Google Drive you are using, that means you are connected to Google. Okay, so it will directly go to it because you need to log in into Colab. If you have never used Google Colab, it will ask you to log in. Okay, if you have already used, fine. So if you double click by putting in the drive, it will automatically, I think I'm able to share this IPv1 files. I'm just sharing here also. Anyway, I'll share with sir. He will share it with you. But I'm also putting here. Okay. So the files I've shared, if you see carefully, those are in IPYNB. So don't try to open it by double clicking on in your laptop or computer. It will not open. So there are two ways. One is you have to import it into Jupyter Notebook and you have to open the file, or you have to put it in your Google Drive and you have to double click on that after putting in the Google Drive. So if you do that, it will open in Colab and you can use it. Okay. And why I'm sharing you this is it'll be easy for you because the code is already there. You can run it and try to understand what I've explained in the video. From there, you can take it easily. Okay. So I'll be sharing all the Python files, whatever I'm teaching. Don't worry. That's why for every concept, I've put a separate files. Okay, and instead of putting in one file, what will happen is it will look if you're doing a project continuously, putting in one file makes sense. So different concepts, because you're just learning new. So I've put it in separate Python files. Okay, and I'm sharing it. Okay, so it'll be easy for you to take it from there on that perspective. So any other questions apart from this one, because on this files and all those things, I've anyway, I just wanted to inform you also, because a lot of people don't know what to do with this Python files. So putting in your drive and opening it is a better way, because even eyes, especially for few people will have Jupyter Notebook issues. That is why I'm not even teaching you in Jupyter Notebook. I'm directly using in Colab only, because I don't want to take any risk with Jupyter Notebook, because a few people will have some issues using Jupyter Notebook. For me, it works fine. Actually, Jupyter Notebook doesn't have any issues, but the speed of the laptops, the able to handle applications, your RAM, everything plays a very vital role, and Jupyter Notebook is also very heavy software. So rather than that, if you have internet, better to use Colab. And no need to import any file also. Directly you can put it in the drive and you can double click on it and it will open, and you just have to run it. So apart from that, it is not difficult. So using collab is better in that perspective. Okay. So any other questions we can wind up? If you don't have any, please just let me know. I'm just waiting for your questions anyway. This name entity recognition, we'll do it tomorrow. We have one more, a few important concepts as well. Probably another 2-3 sessions. It will go, and I'll also explain how we write a code for transformers, how the working mechanism of transformers work, because without, if I don't teach the complete concept of transformers, the Gen AI doesn't make sense, because our Gen AI, what we are using is completely working on a transformer. Now we are in the second generation of transformers. So the second generation of transformers is actually developed by NVIDIA. So we will also try to understand about NVIDIA and the new Blackwell technology, what NVIDIA has incorporated into the new supercomputing. Everything we will discuss. How it is contributing to generative AI, how it is using, how it has developed the second generation transformers, which isn't in, which is and fifth generation ray tracing course. So everything we will try to decode one after the other, and try to understand. Yes, Sumakant, if you have any doubt, you can just put it in the chat. We have time, still a couple of minutes. You can just post it in the chat. If you have any questions, I'll just answer your questions. Sorry. Yes, please. Another minute. Please text me if you have any questions. Please ping me. Sir or ma'am, Amar, you are there. If you are there, we can wind.
Yes. Yeah, sure.
Because no questions, I guess you can just wind it up. Or probably we can wait till 9. Yeah, it's 9 anyway. Yes.
Done. We'll wind up for the day. Thank you,
Sure,
sir.
sure.